PipelineDB is a streaming SQL database. My guest, Derek Nelson, is the CEO of PipelineDB. Derek, welcome to Software Engineering Daily.
Thanks for having me, Jeff.
What is PipelineDB?
So PipelineDB is a streaming SQL database that actually has a fully functional relational database stored on the same hardware as the stream processing engine as well.
And what problem does PipelineDB solve?
So the big problem, it's a pretty general problem, running continuous computations on streams, which is becoming a more and more common problem that people are running into, and they're solving with all sorts of other frameworks and systems that are starting to spring up. But the general problem is running continuous computations on streams. And in particular, the types of computations that we focus on being really good at are aggregations. So anytime you're shrinking down the data that's coming in, counting things, and stuff like that, that's the type of stream processing that we optimize the system for.
How is the continuous continuous aggregation or continuous view solution differentiated from other database solutions on the market?
Yeah, so there are a couple of main differentiators here. A lot of the really popular stream processing systems that are out there in use today expose most of their functionality through an application development framework, essentially. So you're writing Scala code or Java code or something like that to express these types of continuous computations you want to run on streams. Whereas the approach that we've taken is that we've actually offered all of our functionality through a query language and a ubiquitous one, SQL, that everyone is already using. So people don't necessarily have to know how to write real-time streaming code to use our system. They just have to know how to write SQL queries, which is a pretty common skill set nowadays. So that's a big differentiator. The other main differentiator, as I mentioned before, is that we have a fully functional relational storage engine integrated on the same exact hardware as the stream processing engine. So with a lot of other stream processing systems out there, it's up to the developer to figure out how they want to store state as they're doing these streaming computations. You have to have some sort of state. If you're doing a running count of something, you need to store that count somewhere so that you can increment it as new information flows through the system. And a lot of times that's handled by deploying some sort of external storage framework like Cassandra or HBase or something like that. Those are pretty common for storing streaming state. Whereas we have a fully capable relational storage engine on the exact same hardware. So it's all one unified product, which makes things a lot simpler.
Where did the idea for PipelineDB come from?
Yeah, so there was definitely a need that we had for this product. So the story sort of starts at my last job. I worked at an advertising technology company called AdRoll, based here in San Francisco. And during my time there, I was the engineer primarily responsible for building out and scaling their data infrastructure. And as an advertising company, their workload was extremely data intensive. So we were pushing the envelope in terms of what companies were doing with data back then. And we developed a lot of really cutting edge streaming infrastructure that could process torrents and torrents of information in real time and do all sorts of valuable and interesting things with it. But we ended up dealing with a lot of complexity because back then there weren't a lot of tools out at that point. So we built a lot of stuff in-house. We stitched together a lot of existing open source frameworks with custom application code and then put more custom application code on top of that to express the streaming computations we want to do. And so fundamentally, it was really complex. And so PipelineDB is something that I always wanted on the data team at AdRoll because it's just so simple. So we're solving a lot of the same problems that we solved back then at AdRoll, and we're doing it in a much more simplified way that's easier for the developer to just get something up and running right now.
I've worked at an advertising technology company also, and I can vouch for the fact that it's essentially like the levels of data that you would have at a like a market making technology company. It's you basically just got constant feeds, constant streams of data coming in, and it's basically just as fast as you can wrangle the data, there is data for you to wrangle. So your architecture at AdRoll included Kafka and Storm and HBase. What were the major problems that you encountered at the intersection of these different technologies?
I think there are probably two fundamental problems. I think the biggest one was the operational overhead. Having to develop the operational expertise to run HBase in production and run Storm in production and run Kafka in production, three very different systems Knowing how to operate those at scale in production took a lot of time, a lot of effort, a lot of late calls in the middle of the night and things like that. So the operational overhead was a big pain point. And I think the second issue was having to write custom application code to express the computations we wanted to do. Because fundamentally, I mean, we were doing, at the end of the day, and what a lot of companies are doing with these kinds of data workloads is that they're really aggregating stuff in the simplest way. They're counting things. And so those are the types of computations we were doing. But it ended up being, I felt, a little bit unnecessarily complex to express those computations with application code. And so that was another pain point for sure.
As I understand, you met with over 100 different data-driven companies to learn about their pain points when you were architecting PipelineDB. If that's accurate, what did you discover?
Yeah, so that's definitely accurate. And the reason we did that was because when you set out to build an infrastructure product, the development period is really long. So you really want to make sure you're set off in the right direction, obviously, before you go into development mode for a year or more. You want to make sure you're solving as many problems that apply to as many of these companies as possible. And so we wanted to talk to all these different companies and figure out what the common pain points were. And to answer your question, what we discovered is that everyone was basically building the same thing, something that looked very much like the architecture we had at Admiral. There was a lot of people were using literally the exact same thing: Kafka, Storm, and HBase or Cassandra, something like that. And they all had the same problems that we had at Admiral. They suffered from a little bit of an operational overhead that was expensive for them, and they found it difficult to write streaming application code and deploy it when they made changes and things like that.
So we're going to get into the engineering behind continuous views and other things in PipelineDB, but I want to ask one more question about the macro. You wrote that the primary consumer of information is becoming software itself and not necessarily analysts who need to frequently run ad hoc queries on granular data, end quote. I find this really interesting, and it's nice to hear something that's like somewhat opinionated. And I think it's true. So can you explain that quote in more detail?
Yeah, so to give it some context, I think the quote was mentioned in probably somewhere around our philosophy of why continuous views are valuable, because they essentially pre-stage all this information. They run the computations on it continuously so that all the information that's in them is essentially ready to be read. There's no further processing that has to be done on them. And to get to your point, that's why that's valuable, because we believe that the primary of information is becoming more so applications than people. And to give you a couple of examples of what that means, you could imagine like an e-commerce site or someone who they have software that's continuously recording how people are behaving with their website, where they're clicking, what they're buying, things like that. That's all put into a database, probably has some computations run on it that allows other systems to recommend items to those people that they might be likely to buy, or change the price that makes them more likely to buy, or something like that. There's not a human involved in that process. There are algorithms reading from this stream of information. Another example is something like some sort of monitoring and alerting infrastructure. If you're monitoring certain server metrics and you want to know, you want something to happen if some server becomes overloaded or runs out of memory or something like that. There's not a human constantly looking at 1,000 different servers to figure out if there's something wrong by eyeballing stuff. All that information is being fed into an algorithm somewhere that determines if there's a problem, and then triggers something to happen so that at that point a human can intervene. And even something as simple as a dashboard, that's technically an application viewing information. The only user input that's really being given are things like date ranges and stuff like that, which are basic it's basically a parameterized query, but even then it's still an application reading the database and then sending the user this aggregate information that can be displayed in a dashboard. So I guess the point is that no one's really storing huge amounts of raw data and running an analyst, running ad hoc queries on it to derive conclusions and things like that. Software is increasingly responsible for that.
Yeah, so I think we should come back to that at the end because it's a really interesting macro topic, but we should get into the engineering. PipelineDB's fundamental abstraction is the continuous view. What is a continuous view?
So a continuous view is it's a lot like a regular SQL view. So say you have some SQL table and you want a view over that table that modifies the way it looks when you query it. That's pretty standard in the SQL community. And a continuous view again is much like a regular view, except that it selects from a combination of streams and tables. And then the result of this in the continuous view runs some continuous query that you've defined beforehand. So it's just like creating a regular view. You would do create continuous view. Let's say select count star from stream. So the query is select count star from stream. Even if you're sending billions of events through this continuous view, the only thing that's actually stored in the database is this one row that has the count of all the events that have been through the system, and it's just constantly updating. So to reiterate, a continuous view just selects from streams and tables, runs a continuous query on that stuff, but it only stores the output of that continuous query in the database itself.
And what is an example of a data pipeline where a user would want continuous views?
I think I'll mention the dashboard example again.
Sure.
That's a really intuitive example because what you're doing with the dashboard is essentially summarizing raw data over time. You might bucket it by hour or day or minute or whatever so that you can, it's a manageable amount of information to send down to a user. And rather than storing all of that information, all of that raw information and doing that aggregation on the fly when the user wants to see a page in the dashboard, the continuous view can preemptively do that so that when the user queries the dashboard, it's just a simple read from this table that's already aggregated. So that's a really intuitive use case, I think.
Sure. So to drill down into a bit more granularity, you can maintain the dashboard use case. What if you wanted to do text search filtering on something and have it propagate to that dashboard?
Yeah, so that's definitely feasible. Our product is based off of the PostgreSQL 9.4 core code base. So anything Postgres can do, PipelineDB can actually do with continuous views as well. And Postgres ships with reasonably efficient text search support, but you could easily do that in a continuous view. It's probably not the ideal tool for high performance text search, just like Postgres isn't, but for simple stuff like filtering and trying to pluck out certain strings you see in logs and things like that, absolutely, that would be a valuable use case, especially because it's in line with our philosophy behind the product, which is reducing these data sets, right? If you only want to pull out strings that match some filter, then that makes a lot of sense to do with a continuous view.
What about geospatial filtering?
So geospatial filtering, again, we ship with our product. PipelineDB has support for everything that PostGIS supports, which is the de facto standard geospatial extension for Postgres. So yeah, we can do all that too. So if you wanted to look for a bunch of sensors that in the last 5 minutes or something, you only wanted to look at the sensors that you've seen in the last 5 minutes in some predefined radius around a city or something like that. Everything outside of those parameters would be discarded. And again, that would be also reducing down the size of the streaming data set too, which is very congruent with the philosophy behind continuous views.
PipelineDB is designed to excel at SQL queries that reduce the cardinality of streaming data sets. What does this mean?
Yeah, so cardinality is basically the number of unique things in a set of things. So picture a log file, and each line in the log file has the exact millisecond that log line was generated, which is pretty common, or some sort of timestamp, right? So if you looked at the cardinality of timestamps in this giant log file, the cardinality would be huge. You have one item per millisecond, something like that, and no one's ever going to read that data in its raw form. So reducing the cardinality here means something like truncating the timestamps down to hour and then counting things up. So bucketing all this information and counting things up by how many log lines did we see during this 1 minute? How many did we see during this 1 hour? So it's really a fancy way of saying summarization, aggregation.
What is virtual data?
So virtual data, so I'll go back to the select count star from stream example. And to do that, let's think about how you do that with just a regular, let's call it a traditional SQL database. If you had, a billion rows, you've dumped all of them into some huge SQL database, and now you wanted to know how many rows are in this table. So you run select count star against that table. It reads through all that physical data that's stored on disk, and then returns the count to you. Whereas with PipelineDB, all we're storing is an actual count. And so we think of all the data that's been discarded after it's already been counted, we think of that as virtual data because it doesn't actually exist in the database, right? We don't have to count a billion rows that physically exist on a disk because we have the count already available to us. And so we think of those billion rows that went through this query as virtual.
Many applications have this continuous update feature of PipelineDB. They have the continuous update in the application layer. Why is it better to have that continuous update in the database?
Yeah, I think it depends on the use case. So in that sense, so I'm assuming you mean something like I don't know, some client that's just receiving updated counts for.
Yes, exactly.
Yeah. Okay. So in that case, you have to have somebody actually listening to the database, right? You have to have someone observing that information. Otherwise, nothing's really changing, I guess. Whereas with PipelineDB, no one has to be looking at the database. It's always spinning. It's always continuously distilling information. And then whenever you want that up-to-date information, it's just a query against the database. It doesn't require anyone to sort of be observing for these changes to actually take place.
Maybe this is sort of a naive question, but what do you define as a database?
What do I define as a database?
How do you define the term database?
Oh, that's a good question. Nowadays, I guess it's becoming a little bit more and more complex and fragmented. Let's see. I guess I would define it as anything that stored information that could be retrieved with some sort of query language. So something a little bit more, I guess you could call a file system a database, but maybe that's a little bit too low level. I would define it as something that stores raw information that can be retrieved with some sort of language.
Yeah, I mean, it's obviously semantics, but I mean, do you think that would you classify S3 as a database, or is Dropbox a database? I guess it's like a philosophical question. In some sense, it doesn't really matter, but maybe it's worth saying that like the idea of a database doesn't really have a fixed target.
Yeah, no, totally. I think that's a good point. I would call S3 a database. It's very much a key value store. But yeah, I think probably the specific definition of a database is sort of going away because now you just really have problems that systems are solving. Databases are becoming more and more specialized because specialization is the easiest way to get scale. That's why you're seeing so much fragmentation in the data processing space right now. So many unique purpose-built products emerging. You have less and less products that are sort of one-stop shops for all of your information because to get scale for a particular workload, you have to give everything up that you don't need that system to do. And I think that's the basis behind why you're seeing so many unique, specific data products emerging.
Right. Like I was talking to Rethink DB recently, and I was like, this thing doesn't seem like a database. It seems like an application.
Right. Yeah, it's definitely a term that probably doesn't make that much sense anymore.
Okay, cool. So what is the full stack architecture when you have a database like PipelineDB that's continuously updating your views?
Mm-hmm. So the full stack architecture, I mean, I guess it would look very similar to the same architecture you'd use if you were just using like a regular Postgresql database or something like that. Because as I said, you don't have to have clients connected to this database listening for changes that are happening or anything like that. It just sits there and constantly updates, and the information is there when you want it. So it looks very much like any other relational database deployment. And the other cool thing about our system, and one of the reasons why we chose to base it off of a ubiquitous product like PostgresQL, is that it works with any client libraries that currently can talk to a Postgres database. And Postgres is very standard, so really it works with any clients that can talk to any SQL database. So we don't have our own proprietary API or proprietary client libraries or anything like that. All of the client libraries that people are already using to talk to their SQL databases will work with PipelineDB seamlessly. So yeah, to really answer your question, it would look very similar to a PostgreSQL deployment right now.
So with that in mind, what does the migration process look like? If I'm some guy that's just got a Postgres database and I want to migrate to, or maybe you think of it more as an augmentation. If I want to get PipelineDB functionality in my Rails app, my Node app, whatever that has Postgres, what is that migration process like?
So I think there are two questions here. The first one is how do you migrate an existing, what we call vanilla Postgres to PipelineDB? And then the second question is, I'll get to that. But so if you wanted to migrate an existing PostgreSQL deployment to PipelineDB, it would be a matter of just exporting all of your tables, all of your data, and then importing it into PipelineDB. As long as you're using something compatible with Postgres 9.4, it would be that simple. And in terms of adding a PipelineDB capability to your application, it would be just a matter of spinning up a Postgres instance or installing Postgres on whatever hardware you have, and then just connecting to it like it was a regular Postgres database. There are actually no code changes or anything like that would be required.
What are some strategies, what are some patterns that you've seen that people have implemented using continuous views that have changed their application architecture?
Yeah, so let's see. I mean, the first one is, I keep going back to the dashboarding example because that's just a slam dunk use case that pretty much everyone
that's like every company.
Yeah, so anyone who has any sort of like dashboard they're using, they've used PipelineDB to make things a lot more efficient by pre-aggregating all that stuff so that the front end just has to do a basic read. Another really interesting use case that we're seeing spring up is a lot of companies who have massive, like torrential amounts of data that they have this stuff streaming and they can't really analyze it until after a certain time because there's just so much of it. It requires so much processing power to just make sense of everything. So what they're doing is they're taking a percentage of that fire hose of data, whether it's like 1% or 2% or 10%, and they're piping that into like one small PipelineDB instance. And the cool thing about that is when you have that much data, if you're looking at 1% of a massive amount of information, it's still statistically significant, and it's going to look similar in shape to the 100% of data. So it allows them to get access to what the like shape and feel of this data looks like by just offloading a small sample of it into a PipelineDB instance, which cuts down the delays for them a lot.
Could you talk about the latency guarantees, how long it takes for a raw data stream to be converted into the refined queries that are provided by a continuous view?
So that really, there are no guarantees there. I mean, it totally depends on the query you're doing and what the complexity is. So it's hard to say what the guarantee is, but one like sort of rough benchmark that is has been pretty accurate to go by if you want to figure out like how much performance you can get out of a PipelineDB instance on your hardware. You'll saturate the network interface most likely before you saturate PipelineDB. So the network interface, however much information you can take through the network, whether it's 10 gigabits or 1 gigabit or whatever, that's probably the rate that PipelineDB will be able to process information if you want to get an idea of performance.
Could you talk about a little bit more about how the internal implementation of PipelineDB works? So like I understand that you have raw data streams and something is listening to the raw data stream that refines the raw queries, the raw data into refined queries of the continuous view. But could you talk a little more about how that, and that's about the level that I understand. I mean, I understand a little bit more, but if you could describe to me a little bit more the lower level implementation, what that looks like.
Sure. Yeah. So everything happens with two processes that we call. One is the combiner, and one is the worker. And depending on how many cores you have, you can parallelize those as much as possible. So if you have 32 cores, you might configure your pipeline to have 4 combiners and 28 workers or something like that. So I'll start with the worker because that's sort of the edge of the system. The worker is a process that reads directly from a stream and runs a continuous query on it And the continuous query is just whatever you define with the view. So let's go back to count star. Let's say that's what the worker is running count star. And so the worker reads what we call a micro batch of data. So that's a configurable parameter. I think it defaults to 10,000 right now. So the worker will read 10,000 events, run the continuous query on those 10,000 events, and then generate what we call a partial result. So let's just follow what this query, what the flow looks like from here. So the worker will read 10,000 rows, run select count star on it, and so now it's got one row with the number 10,000 in it. And so once the partial result has been generated, that partial result gets sent to the combiner process. And the combiner process, its fundamental purpose is to combine these partial results continuously with the permanent information that is actually on disk. So let's say we've already counted 1 billion rows, and now we need to merge in this row with 10,000 because the worker just counted 10,000 events. The combiner takes the row with 10,000, and then it combines that with whatever's on disk. So then we'd have 1 billion plus 10,000. That number would be the new row in the database. And as soon as the combiner commits that to disk, it would be visible to any clients reading from the continuous view.
Awesome. That's very useful. What is your definition of a data stream?
A data stream. So that might be even more general than the other question about what a database is.
The database.
Yeah, I mean a data stream. It's really interesting if you think about streams, because really anything, especially information, can be conceptualized as a stream of changes. Your bank account balance is just a stream of withdrawals and deposits. And so that's sort of how we think about streams, is just a flow of changes, and a continuous view is just the culmination of all of those changes at that particular point in time. So it's a pretty general idea, though.
So PipelineDB is iconic of the movement from batch processes to streaming processes. I did a week of shows about big data, and that was definitely one of the themes throughout the week. Could you explain how you see this movement from batch to streaming?
Yeah, so I think the interesting thing is I think they'll always both exist in some respect. You always want to be able to retroactively go back and process stuff, and you do that with a batch system. But yeah, I don't know. I mean, I think that the only reason that streaming hasn't been more predominant in the past is just because technologically it's harder. Everybody wants streaming data. Everybody produces data as streams. Data isn't produced in batch by users anywhere or machines. They don't batch up data and then send it somewhere where it's processed in batch. All information pretty much everywhere is being produced as a continuous stream. But processing that data as a continuous stream turns out to be a lot harder than processing it in batch. So it's taken a little bit of time for various industries to catch up to that. But I definitely see it as a predominant way of analyzing information in the future, because, again, that's how all information is produced, as a stream in the first place.
What are the trends and technologies that characterize the batch to streaming? I guess if you think that they're going to be persistent throughout time, then maybe it's not as much of a movement as I'm characterizing it as. But what do you think are the most important trends and technologies within this movement? Probably
one of the most important things is making stream processing as easy as possible. It's still not the easiest way to process data, but as I said before, it's the way that all information is being produced, and I think eventually it will be the predominant way that all information is understood and analyzed. So making sure that's as easy as possible for people who aren't necessarily infrastructure engineers is really important. And if organizations whose primary purpose isn't to create large-scale infrastructure software, if they could have that capability to process information the way that leading data-driven organizations are, then that's a big deal. So I think making it as easy as possible, making stream processing as easy as possible is a big important trend.
What is a sliding window?
So a sliding window is, let me give you a good example. So let's say I want to understand what the average let's say the average temperature of a server is over the last 5 minutes. So I don't want to take the average after 5 minutes of data. Like let's say at 1 o'clock I take the average and that's a data point. Then I build up a bunch of other data until 105, and then I take the average again. A sliding window actually always considers the last 5 trailing minutes from now, essentially. And so the value is, even if you're looking at 5 minutes, 5 minutes of data, the value of that data is constantly changing with time. It's sliding along with the progression of time.
And how does PipelineDB implement a sliding window?
Yeah, so it's pretty simple how we do it. You essentially run a continuous view with a where clause that says where the arrival time of the events is between now and 5 minutes ago, essentially. And then every time you query the continuous view, it will only show the last 5 minutes of data. And the hard part about that from a engineering standpoint isn't generating that actual result. It's easy. The hard part is actually cleaning up data after it's expired. So if there's a sliding window and I only care about the last 5 minutes of data, I will never care about anything that is now outside of that window, which means our system has to clean it up efficiently. Which it does sort of in the background.
What is a probabilistic data structure?
So probabilistic data structures are super useful on streams, and in a general sense, what they are is data structures, usually data structure and algorithm combinations that facilitate some sort of highly accurate estimate of some value, but it does show like an estimate. So for example, if you want to count the number of unique users you've seen in a stream of events, that's to do that with perfect accuracy, you need to store every event you've ever seen, because if a new one comes in, you have to say, well, has it been seen before? And so there's no way to do that with 100% accuracy on a stream, because a stream is infinite, theoretically. It never ends. So you can use, I'll give you an example. One probabilistic data structure we use is called hyperlog. And what that does is it allows you to estimate the cardinality of a set. So again, that's just the number of unique things in a set of things. So if we wanted to estimate the number of unique users that I've seen in this page view stream or something since the beginning of time, hyperlog can do that with using a constant amount of space. So the data structure, once it's fully saturated, won't actually grow. And the estimation that it yields is, the way we have it configured, is extremely accurate. So you can estimate billions and billions of unique things with about a little more than 99% accuracy, with almost no space at all, like tens of kilobytes.
Fascinating. So if you're with a hyperlog, as the input stream increases in velocity, how does the performance or the accuracy degrade?
So the accuracy. The performance is pretty constant. The data structure is, the performance is essentially proportional to the size of the data structure, which basically doesn't change. It starts out a certain size and it always stays that size. So performance doesn't necessarily degrade.
Well, it's size of the data structure relative to the size of the data stream, right?
So the size of the data structure will never grow after a certain point. So, well, if we're talking about hyperlog in particular, you can keep it at a certain size, and it doesn't matter how much data you've ever seen. It will always stay the same size. All the space is essentially pre-allocated, and then a bunch of values at different positions get changed in that pre-allocated space as information flows into the data structure. And so accuracy is it's really, the accuracy is the worst when it's really, really small in the very beginning. But the more elements you add, it sort of converges on the error rate that you've configured.
Interesting. So how is a hyperlog implemented under the covers in PipelineDB?
So we actually, it's a pretty common data structure. So we actually, I don't know if you're familiar with Redis, but it's got a really, really nice hyperlog implementation, and ours is almost verbatim Redis's. I mean, their copyright notice is in our hyperlog implementation. So we use most of their implementation with some changes for us. But yeah, there are lots of other implementations out there, but the Redis code is absolutely gorgeous.
Just to get inside baseball, could you articulate any of the differences between your implementation and the Redis's implementation?
Let's see if there's anything fundamental. I mean, there's nothing like fundamental.
Okay.
Actually, yeah, there's nothing that's fundamentally different. It's not like fundamentally faster.
Okay. That's fine.
It's pretty similar. Yeah.
Okay. Let's talk about a little about the other probabilistic data structures. What is a Bloom filter?
So a Bloom filter is actually really similar to hyperlog. So the operation that hyperlog supports is essentially set cardinality. You add all these elements to it, and then you can estimate the set cardinality very accurately. You can also do that with a Bloom filter, and it also adds another operation, and that's set membership. So I can add a bunch of elements to this Bloom filter, and then I can, I have some incoming new element. I can ask the Bloom filter, does the Bloom filter likely contain this specific element? And so at the expense of that additional operation, Bloom filters are actually much larger than hyperlog logs, but they're very similar in that they support set cardinality with the additional operation of set membership.
And how did you engineer a Bloom filter? Was it another case of just having a pretty straightforward reference implementation?
Yeah, I think Bloom filter has been around for a while. It's pretty well understood how to implement them. We implemented ours ourselves, but I mean it's certainly not our invention.
Sure,
it's a pretty standard algorithm. So
what about a T-digest? I hadn't heard about that.
So T-digest is for accurately estimating basically quantiles. So you could say, given this value, what percentage quantile does it exist in? Is it in if you want to look at the top 99th percentile of values, or you want to figure out if this value is in the bottom half or the upper half of all the values you've seen. To do that accurately, again, with a stream is impossible because they're infinite. And to do quantiles accurately, you essentially need to sort all of the data that you're looking at, which obviously you can't do with the stream. So T-digest is a data structure that allows you to estimate quantiles pretty accurately and pretty efficiently.
So the usability of these probabilistic data structures seems to have a lot of synergy with the core offering of PipelineDB of just having a continuous view into something. Are your customers using probabilistic data structures in any interesting ways?
Pretty much everyone who's using our product uses distinct counting, which internally uses hyperlog log. So that's definitely the most popular probabilistic data structure that our users are using. That's just with count distinct, which pretty much everyone's doing.
Does PipelineDB support replication?
So Postgres supports replication, and all that already works because we're based off of the Postgres core. We do support replication.
Could you describe some about, for listeners who don't know, what are the differences between Postgres and MySQL?
To be honest, I don't really know too much about MySQL. I've always been a Postgres user. I couldn't really tell you anything interesting there.
Okay.
I know that fundamentally, and one of the reasons we chose Postgres, because I think their development philosophy is a little bit more disciplined and slow. So it took a while for Postgres to catch up to MySQL in terms of features and things like that, because the speed of development is slower in the PostgreSQL community. But what you get with that is an extremely high level of quality, both in terms of the database's stability, how the code base is organized. So it makes it really easy for us to piggyback on top of it because it's such a well-organized code base, and things like that. And I think it's really starting to catch up now. But that's the biggest difference that I've seen.
This is a question you may not have an answer to, but do you have an idea why Heroku supports Postgres and not MySQL?
I think I honestly I don't know off the top of my head.
Would you have any guesses, or that's just a random question that popped in my head?
Yeah, I think it's probably more stable for general use. I think MySQL is a lot faster and probably better than Postgres at the simpler queries where you need a lot of performance. But I think overall, Postgres is just a more stable, high quality system for the general case. So I'd imagine they probably thought the same thing, but I don't know for sure. I couldn't tell you.
Are there any other interesting customer use cases you could talk about that highlight how people are using PipelineDB?
One that's been really valuable that we've seen come up quite a few times is the real-time monitoring of A/B tests. So we have one customer, really big web property in the top 50 websites in the world. They're using us to monitor the results of A/B tests they're doing to their site in real time. So if they make a tweak to an image or a button, they want to see immediately how that affects the rate at which people buy that product, because that's so closely tied to revenue, obviously. And the way they were doing it before is that they were dumping all that A/B test performance data somewhere, and then they were analyzing it sometimes hours, maybe even a day later. So they wouldn't know immediately how effective the A/B test was, whether it had a negative effect or a positive effect. They wouldn't know for a while. Whereas now with Pipeline, they can watch how that conversion rate changes in real time very easily, which is obviously super valuable to a company that does e-commerce at that scale.
To give a more granular view into what it was like for that company to implement, to integrate PipelineDB into their workflow, could you provide some like speculative description about what the implementation, what the process of migrating, of augmenting their workflow to include PipelineDB in order to fit that use case? What would the code have looked like? How much code would they have been writing? What would the developer experience have been like?
Yeah, so we have a pretty good idea of what the integration looked like. There was, in terms of sending data into PipelineDB, they had a 50 or 100 line Go program. It was super small. It would just read from their Firehose and then insert that in the form of SQL insert statements into PipelineDB. So that's how they got data in. It was actually pretty seamless. And in terms of getting data out and viewing these results, that was also pretty seamless as well, because they have a data backend that the various users in their company can go to and issue queries to various data systems, and then come back and look at the results later or look at the results then. So all they did was they have like a drop down menu that says select the data source, and then there's a query box that says that you run the query, and then the query comes out in the form of like a table, and they basically added PipelineDB as a source to that, which was pretty seamless because they have a lot of other SQL products that they were using in that system as well. So it just looked to the end user, it looked like a new data source appearing in a drop down box one day.
Interesting. So I want to come back to the discussion we were having at the beginning about the fact that the primary consumer of information is becoming software itself and not necessarily analysts. So is that to say that are you seeing PipelineDB be adopted more in systems that are not heavily augmented by a fleet of data scientists?
Yes, absolutely. I mean, it's a system like Pipeline is still useful for doing exploratory analysis by data scientists and stuff, because you can still continuous views just behave like regular tables, so you can run further queries on them. You can join them on other tables, distill them down, and things like that. But I think like a more traditional ad hoc database that can look at granular data and run on-the-fly queries in real time is more conducive to bringing out the full power of a data scientist. So yeah, we expect to support applications more so than people doing ad hoc queries. Absolutely. So
as the Firehose increases over time, I mean, just the general application stack Firehose across the world. I mean, this is like, what is it? 90% of the world's data was made in the last 2 years. Phrases like that. Do you think that PipelineDB could create sort of like a polyglot persistence layer where you've got your Firehose and your Firehose gets reduced to pipeline rows, and then people will perform. You could still have data scientists performing ad hoc queries across their reduced, refined PipelineDB tables. Do you think that's a plausible future?
Sure. I mean, that's probably part of it. We certainly don't expect to be like the one-stop shop for everyone's data. We're one extremely valuable tool in their tool chest. So I think that's part of it, but certainly not all of it.
Interesting. So what are some other databases that you think have synergy with PipelineDB?
Let's see. I mean, definitely, obviously, Postgres. That makes a ton of sense.
Sure, absolutely. I was thinking more from a polyglot persistence point of view. Are there other databases that make sense to augment the functionality of PipelineDB with?
Mm-hmm. Yeah, so certainly Postgres. That's an obvious one, as you said. The other one that comes up a lot, that a lot of people who are using Pipeline are doing this. They're using it in conjunction with Kafka. So Kafka is really awesome at being like the general message bus for all of your streams of data. It's extremely ubiquitous, and it's probably going to continue to grow in its adoption very fast. And so that's something that works really well with any streaming product, and certainly with Pipeline as well. A lot of people are using Pipeline in conjunction with Kafka.
Could you describe more about the implementation of what people's? I mean, I've done a couple shows on Kafka. I have a general understanding of it, but what do you think is so important about Kafka? Like, how does it augment, or how does it make for a great message bus that feeds to PipelineDB?
Yeah, I think that the main thing is just its ubiquity. I don't know too much about the implementation. I know that it's a great product. I've used it in the past, and I think really it's just the ubiquity that makes it relevant for PipelineDB. Pretty much anyone doing anything at scale with streams is using Kafka. So if they want to run computations on the streams they're doing, it's very likely that stream is going to be coming out of Kafka. And so that's why I think it makes sense in the context of PipelineDB, just solely because of its ubiquity.
Right. So you write that PipelineDB aims to leverage three powerful components: SQL, the relational model, and open source. What does this mean for the future of PipelineDB?
So I think probably the most important thing there that we haven't talked about yet is the open source aspect. I think any infrastructure product that thrives in the future is going to have to be open source. It's increasingly the case that developers and engineers are making the big fundamental decisions about the infrastructure tools that they want to use for their to base their products on, and the way that they find out about things and the way that they gain confidence in things is by trying them with basically no overhead. Engineers aren't getting calls from salespeople to find out about the greatest new infrastructure products. So we really strongly think that open source is completely critical for any infrastructure products that are going to thrive in the future.
Yeah, I had a conversation with the CEO of MemSQL, and MemSQL is, of course, a closed source company, and I don't know, it's interesting because and as I've talked to all these big data companies, it seems like there really is a tension between the closed source business models and the open source business models. One of the issues that the MemSQL CEO, which again is closed source, pointed out is that with the open source business model, companies may have an incentive to provide a type of service that has some lock-in to consultants, which is, you see this in the Cloudera model or the Hortonworks model. So it's kind of a hazard that you can actually avoid if you have a purchasable closed source solution. Have you thought at all about the tensions between those two business models?
Yeah, I'm sure Eric would totally disagree with my opinions on open source thriving in the future, but yeah, it depends. I think it works really well for MemSQL because they took at least in the beginning, they took a very well-defined problem.
It was the CTO. I just want to clarify, not the CEO.
Oh, okay. Well, yeah. Regardless, they took a very well-defined problem in the very beginning of their company, at least with their product. They said, we'll just basically take MySQL and make it insanely fast. So people that are buying that type of stuff, they know exactly what they're getting. And so it's easy to quantify that. You could say, if I could speed up your MySQL cluster by 1,000x, what's that worth to you? That's an easy thing to figure out. It's quantifiable. So they've had a brilliant sell. For us, our product is a little bit more out there in terms of philosophy, with continuous views and like not storing all this data. It's a little bit more out there, I think, and it's a little bit more of a bet that we're making. So we can't tell people exactly what they're going to get because it's so new and there's not a lot of stuff like this out there yet. So we have to facilitate adoption in order to figure out like what this value is and how people end up using this new capability. I mean, we've already seen use cases that we hadn't anticipated spring up because we've just let everybody use it. So I think for a product like ours, that's a little bit very unique in my opinion. It's important to just put it out there as easily as possible so that people can experiment with it and figure out how it adds value to them.
What types of use cases that you didn't expect are you seeing?
So the one we didn't expect was the sampling of fire hoses. So I mean, we kind of thought about that, but a lot of people have actually been doing that, which is awesome. It's a super valuable use case. Another use case we hadn't really thought about is time to live. So a lot of databases, especially key value stores, when you write a row to something, a data store like that, you can a lot of times give it what's called a TTL, a time to live, and then after that TTL, if the TTL is 30 days or whatever, 30 days go by, and then that data point gets erased, it gets discarded. So you're not just constantly growing the database forever. And so people have actually used Pipeline in conjunction with sliding windows to essentially have regular SQL tables that effectively have a TTL, which is actually pretty hard to do right now. So they can say, I only care about the last 30 days of data. Don't keep filling up my disks for anything that's older than 30 days. And you can do that with a sliding window.
So we're almost out of time, but I did want to ask, when you were going to those 100 different data-driven companies to learn about their pain points, did you discover any other bizarre pain points that maybe are totally orthogonal to the conversation we've had? Or not orthogonal, just other things you discovered?
Nothing jumps out at me off the top of my head. To be honest, the conversations were always very, very similar. There was a pretty consistent pattern, as I said earlier in the conversation. I can't think of anything that jumps out at me that was strange or surprising.
Fascinating.
I'm sure there was something, but nothing that stands out right now.
Okay. Well, Derek, thanks so much for coming on to Software Engineering Daily. It's been a real pleasure to have you on.
Yeah, thanks for having me on, Jeff. It was a great time.